thank you for invitation. I'm very enjoyed of conference, wide articles range. And future survival technical systems might be based on self-diagnosable system with a long time of life. Thus, the A models for distributed computing resources may be an efficient mechanism for a system reconfiguration under multiple failures. The cell interactions, fault information in such system must be considered as syndromes. It is the main theme of this lecture, of this article. Why? Because with the interaction between elements in the systems may be considered as a syndrome, and these syndromes might be cloud computing models with a broad restriction on element behavior. Some of these will be considered. And now, shortly, this article we consider some very simple model which have some interacted elements, and these elements may have reconsider the whole system as a system diagnosis in clouds with a which considered as a diagnostic graph, GVE, where V is a set of system automatic elements, it's especially elements, component processes, nodes, vertices, and so on. And E is a set of directed links. And these links we divide in some decomposed environment. Every graph may be decomposed in some regular subgraphs. G structures LG in such a way that GVE is unit of GVG, subgraphs of this GVE. What is a GVE? G is sub G. This is a number net of VG elements and the interactions links between them, which is considered as EG, sub EG. With the number of elements in every VG subnets, and sub G is equal VG. Now we consider some main structures, the typical structures of this process. The chain, star, and tree structures are the simplest types of these structures. Every unit in chain structure has only two neighbors except two corner units. No, a star structure has only one central unit and set other unit of chains connected with central units. For this structure, we have the common appreciation of this number. Now, what we defined, lemma 1, for a connected graph GVE covered by structure LG, it is a chain structure. We have next equation, n is equal number sum f and g and sub g minus k plus 1. Oh, this is common structure linked with the linked chains for the common structure of this system. Let us consider some graph GVE properties. In this picture, we have a common grandson of this structure. And in the second, next, we define interaction model between elements. One of the most popular models is a PMT model and BGE models. In the left side, we have the test element and unit under test as interacted elements, and the right two models, PMT model and BGE results. Based on this model, we have some chain structure, which we described as LG structure as a diagnostical subgraph, LG. And for this complex structure, for every structure LG, there is syndrome compatible set. We called STS of unit states not contradicted given syndrome. Let us define the number of STS as a given LG and syndrome for this NLG. Then for a given RG may be evaluated as NG as maximum NFL sub G. For every subgraph, diagnostical subgraph of this structure. Then we may formulate the number of SCAs for PMT models as a most popular model as a one-chain structures with the n elements in the MSE is defined as number Fibonacci sub n is equal f sub n minus 1 plus f sub n minus 2 for n more or equal to for beginning values f sub 0, f sub 1 is equal 1. Then we have some lemma. For this structure, we may evaluate the common structure as the evaluation of number of states of the common structure, which we defined evaluates, we discriminate the chain structures from the free structures with the different states of elements. And now we have solid appreciation and less than 2 in R power multiplied the Fibonacci numbers Fn sub Ng for subsystems of this common system. Thus, the minimal number of the states of PMT chain structures with n elements will be n plus 1. Lemma 6, the minimal PMT chain structures LG with n sub G elements with 0 chain structures have the syndrome. So there is description of this syndrome with a control test with a test element and tested element as a sub G E plus 1 is equal 0. Then we can confine some common lemma as a let us L sub 1 sub 2 L sub K as a PMT 0 chain structure G V such as described here. Then the number of states of this common diagnostic graph GVE satisfies the expression n more or equal as a multiplication Fn sub G. That's all main results of this article. Дякую за увагу.